Ladies and gentlemen, welcome back to Let's Dev, where today we're continuing work on a game about squirting squids and the sharks that want to eat them. Last time we started work on the basics, the main meat of the game, which is somewhat of a reinterpretation of Snake. Players must collect ink in order to completely cover a certain area while avoiding dangerous sharks looming above. The concept is purposely simple, so while I continue to contemplate ways to add difficulty to the gameplay, it seemed like the best time to add actual ink to our game about squirting ink. So today's plan will be to add the ink splatter effect to the game, and while we're at it, we're gonna explore possible new ways to handle dealing with the optimization of said effect. And to top it all off, we'll add some much needed vibrancy to the project. Sounds like a solid plan, or liquidy plan. Let's get to the coding. First, in between videos, I set up our ink surface, and as you can see, I got a little carried away. But as the board fills up, you'll notice just how uniform the ink splatter feels, despite being so seemingly random. So hopefully we'll be able to fix that and make the splatter more organic while not completely obscuring any remaining empty spaces. So a new object specifically meant to draw smaller splatter trails was created. Typical variables were added for size, movement, speed, lifespan, and so on. Then a function was created to count down to the end of the effect's lifespan to destroy it, meanwhile moving it in whatever direction was decided. A circle was then drawn based on those variables. And somehow this did not work. While the timer would count down like normal and the destruction code would trigger, the movement portion wouldn't. Tweaking the variables wouldn't fix the issue. In fact, the only thing that would work was to switch the timer system from a function to an alarm. So the alarm was added, variables were reset, and finally we now had a working ink trail effect. The results were far less quote-unquote blocky without obscuring nearby empty spaces. Now this effect is cool and all, but each step is requiring GameMaker to create anywhere from 50 to 100 instances just to pull off this effect. And while GameMaker is capable, there's something I've always wanted to attempt in GameMaker, and this felt like the perfect time to try it out. So next up, we were converting the ink effect to a pooling system. We were going to need a global DS stack and a couple functions. In what I'd eventually call the push function, we'd store the ID of the ink object calling it, and then deactivate it. Then in the pop function, we'd pop the DS stack and use the ID value to reactivate the corresponding ink object and update the code. And finally, in the ink object, the random values applied to the variables was turned into its own function. This way, each time it's called, its values would be randomized. And to truly test the limits, 1,000, yes that's 1,000, instances of ink were created at the start of the room. Their IDs were recorded in the stack and then deactivated. And as you can see, this was a successful conversion. While nothing visually changed, the fact that none of the ink trail objects are ever destroyed and the game hasn't come to a complete crawl means our code is working. And pulling up the FPS data as well as the number of entries in the DS stack shows that the code is in fact 100% in working order. Now here's the thing, I have absolutely no idea if this is even necessary. However, I felt like instead of recreating large number of instances for something as simple as an ink effect, it seemed more efficient to simply pool the instances instead. Not to mention there were also the options of using DS lists and or structs. But debate aside, I was just happy to see the code actually work. Now we can continue this optimization debate in the comments because next we had to finally add color to these colorless ink plots with, well, some color. A color picker variable was added to the HUD as well as an array of colors to choose from. That variable was then referenced in the objects used to create the ink effect, including the bubble. Then a function to choose a new color was added. This function was then triggered anytime the squid had no ink and a bubble had yet to spawn. And the results were, well, they were almost a 100% success. At the end of the ink trail, right before the next bubble was spawned, the ink color would change. And having that random blot of color show up really annoyed me. So many attempts were made to end the trail, choose a new color, and then spawn the new ink bubble, but eventually I realized that I was overthinking things and had the color change on the bubble spawn. However, the bubble would spawn in the same frame that the trail ended, meaning we were no closer to a fix. Until I added a delay. On spawn, the bubble would be invisible for a few frames, then using an alarm, the bubble would initiate the color change code and then set itself to visible. The only downside is a slight delay between the end of the trail and a new bubble showing up, but it's hardly noticeable. And to be honest, adding a delay to bubble spawns could possibly be a good way to add some difficulty to the game. And anyway, the results were a much more vibrant and visually fun version of the game, with better splatter effects to boot. Obviously, these colors are not final. I'll probably choose a better set off video. Regardless, I'm really digging this project so far, including the visuals. The ink splatter looks great, the color idea feels like it really adds to the visuals, and the gameplay, again, while simple, is satisfying enough. So I'm hopeful that next time we'll finally be able to add some new twists to the difficulty. But for now, that'll do it for this episode of Let's Delve. So leave a like if you enjoyed the episode, subscribe and turn on notifications if you haven't already, and leave your thoughts on our progress in the comments. Thank you so much for watching, and I'll see you guys next time.